Till now we have talked about the charging characteristics, but in RC circuit there is a thing called discharging as well. This circuit. So actually till now we have talked about the charging characteristics, but in RC circuit there is a thing called discharging as well. So what happens if we just not simplify, if we just tweak this one? Let's say till now we had this circuit. So now just assume that there is a switch over here, right? There is a switch here, switch like this switch. Let's say there is a switch and it is being connected like this. Okay, so when the switch is pressed, it gets connected to this one, and this is how the circuit was. So what happens if we just change the position of the switch? So let's say instead of writing this, we have just, instead of drawing this, we drew this one. So now this switch is connected to this wire and this circuit is completed, right? So in this case what will happen? We have the same components. We have this R is equal to 1K. We have this capacitor of 500 microfarad. Current will start flowing through this circuit, right? And as this thing, this is a closed path, closed loop. This portion is actually unnecessary for this part. So let me wipe this, erase this one. So now our new circuit looks like this. So what will happen now? So in the previous problem we saw that the capacitor is being charged, and after 5 time constant the capacitor is almost charged to the fullest capacity. What is the fullest capacity of this capacitor? The same amount of voltage that we have in the battery. The same voltage is now generated across the capacitor. So now the capacitor has a voltage of how much? V is equal to 20 volts, right? Current will start flowing through this, and after some time the voltage drop will occur, right? As this thing is disseminating power, so there will be a voltage drop. Okay, and as you can see, I have written down a table over here. I have written down tau, 1 time constant, 2 time constant, 3 time constant, 4 time constant, and 5 time constant. 1 tau, 2 tau, 3 tau, 4 tau, and 5 tau. Percentage of discharged and the voltage of the capacitor at 1 time constant, 2 time constant, 3 time constant, 4 time constant, and 5 time constant, like this. And the discharging characteristic of a capacitor is denoted with this equation. You need to remember this one. This is for discharging. This is not for charging. This is for discharging. And when this discharging will happen? Discharging will happen when the capacitor is charged and it is connected to a resistor and there is a closed path. There is a closed path and there is no battery source connected to it, right? These are some general conditions when discharging will happen. And this is the equation for discharging of a capacitor, and the graph for discharging will look like this, right? It will progressively discharge to 0. Let's draw this like this. It will progressively discharge to 0. So if I tell you what is the voltage across the capacitor after 1 time constant, will you be able to figure out? I think you can do this. So what we will do, the V can be found by using this equation, discharging characteristic of a capacitor equation. So V is equal to e to the power minus, in this case t is nothing but 1 tau. 1 tau is, instead of writing tau, you could have easily write RC, right? RC and RC gets cancelled out. So e to the power minus 1 multiplied with E. E is nothing but the voltage of what? What is the voltage? In this case, you can say the initial voltage, or you can say the voltage of the battery. In this case, no battery is connected, but previously there was a battery, so you can say it's the initial voltage of the capacitor. So this is, in this case, 20, right? 20 volts, isn't it? So we have this 20 volts connected to it, 20 e to the power minus 1, so it will be giving us 7.35. After 2 time constant, it will become 2.70. After 3 time constant, 0.99. After 4 time constant, it will be 0.366. After 5 time constant, it will become 0.134. It will become like this. Okay, so if you are still having doubt, let me clarify this once again. So the question is, what is the voltage across the capacitor after 2 tau or 2 time constant? It can easily be found by using this expression, V is equal to e to the power minus t over RC. So in this case, instead of t, we have written down 2 tau. Tau is nothing but RC. So here we will be having e to the power minus 2 RC. RC and RC gets cancelled out. So we will be having e to the power minus 2, that is getting multiplied with E. E in this case is the initial voltage of the capacitor, or you can alternatively say the voltage of the battery. So in this case, no battery is connected, but you can assume that the initial voltage of the capacitor is actually the voltage that was transferred to it, right? Or you can say, you can simply just assume this to be the initial voltage of the capacitor. You don't have to complicate this thing. So in this case, we will be having 20 e to the power minus 2, that gives us 2.70, right? Like this way. And percentage of discharge can also be calculated easily, like the previous one. This portion has to be multiplied with 100, right? So you will be getting, after 1 time constant, 36.7% is discharged. After 2 time constant, 13.53%, right? After 3 time constant, 4.9%. After 4 time constant, we are having 1.8%. And after 5 time constant, 0.67%. Okay, so this is how it goes. You need to remember this one, and we will now look at a numerical problem.